Welcome to this explainer. Today, we're going to unpack a topic that is literally reshaping the entire world around us. And honestly, by the time we wrap up here, you're probably going to see the tech you use every single day in a completely new light. We're exploring the fundamentals of machine learning. I know, it sounds a bit like science fiction, but it is absolute science fact. So, let's get right into it.
Okay, let's dive into this. You're typing out a text message, and somehow your phone knows the exact next word you're about to use. You boot up Netflix, and it queues up a movie that is just perfectly tailored to your mood. You hop in the car, and Google Maps warns you about a traffic jam miles away before you've even backed out of your driveway. We literally interact with this magic every single day. But how exactly do machines learn to do all of this? Seriously, think about that for a second. There's no tiny person inside your phone frantically guessing what you want. There's a deeply complex system at work here.
So to demystify that system, here is our agenda for today. First, defining machine learning. Second, the 3 types of learning. Third, solving a real example together. Fourth, common mistakes. And fifth, a quick summary and final test. Don't worry, we're breaking this down into bite-sized pieces. All right, Section 1, Defining Machine Learning. Let's pull back the curtain. Simply put, machine learning, or ML, is a method where computers learn from data instead of being explicitly programmed. And I really want to emphasize that last part, instead of being explicitly programmed. Because, for decades, humans had to hand code every single tiny instruction to tell a computer what to do. But with machine learning, we completely shift the spotlight onto the data. The data actually becomes the teacher.
And this brilliantly illustrates the massive paradigm shift we're talking about here. Look at the top line for a second. In traditional programming, humans input the rules, we add the data, and the computer simply spits out an output. It's basically a rigid calculator. But check out the bottom line. In machine learning, we give the computer the data and the desired output, and the machine itself figures out the rules. It literally reverse engineers the logic. This is the exact leap that makes modern artificial intelligence possible.
Okay, so now that we know what it is, Section 2, the 3 types of learning. The first type is supervised learning. This is where the machine learns using labeled data. It's kind of like a teacher guiding a student with an answer key. If we input the size of a house, the output is its price. The system learns the relationship between the two because we handed it perfectly labeled examples. This is actually the exact same tech that reads your emails, spots the labeled junk, and filters out the spam, or analyzes past student performance to predict future grades.
So let's test that right now. If I give the machine both the input and the correct output to study from, what type of learning are we talking about? I'll give you a second to think. Yep, you got it, it's supervised learning. The machine is actively being supervised by the correct answers we provide.
But what happens when we don't have that handy answer key? Well, that brings us to our second type, unsupervised learning. Here, no labels are provided at all. We basically just throw a massive pile of raw data at the machine, forcing it to find hidden structures and patterns entirely on its own. A really practical example of this is customer segmentation and marketing. Let's say a business has thousands of buyers, but no idea how to categorize them. The machine looks at the data and naturally groups similar users together based on purchasing habits, without us ever telling it what those groups should be.
Which leads to a very logical question, and you might actually be asking yourself this right now. If no output is given, how on earth does the machine ever actually learn anything useful? Take a moment and think about what we just covered. The answer is absolutely fascinating. It learns by independently finding hidden patterns. It literally connects the dots that human eyes might completely miss.
And that brings us to the third, and honestly, kind of the most futuristic type, reinforcement learning. This is learning entirely by trial and error. The machine takes an action, gets a reward if it does well, or a penalty if it messes up, and it improves over time to maximize that reward. This is exactly how cutting-edge self-driving cars learn to navigate crazy city streets, or how AI systems teach themselves to beat world champions at insanely complex board games.
To really cement this in your mind, let me ask you this. How do humans learn how to ride a bicycle? Do we sit down and read a textbook with labels, or look for mathematical patterns? No. We get on the bike, we wobble, we fall down. That's the penalty. And when we balance, we keep moving forward. That's the reward. We learn through trial and error. Reinforcement learning is the exact same idea, just applied to a computer.
Let's move to and see how this builds in Section 3, solving a real example. Let's make this concrete.
Here's our raw data scenario. We want to predict a student's pass or fail status based purely on how many hours they study. 2 hours, fail. 4 hours, fail. 6 hours, pass. 8 hours, pass. We have our inputs and we have our perfectly labeled outputs.
So, how does a machine digest this? Step 1. It registers the input, which is the study hours. Step 2. It registers the output, which is the pass or fail result. Step 3. Because we're using supervised learning, the model looks at the data and writes its own rule. It realizes, okay, less than 5 hours of studying equals a fail, and greater than 5 hours equals a pass. Boom. The machine has officially learned the pattern.
And notice how we can visualize that exact logic right here on this graph. Along the x-axis at the bottom, we've got our study hours. Along the y-axis on the side, we have our pass or fail results. When the machine plots those points, it mathematically draws a very distinct line separating the passes from the fails right at the 5-hour mark. That dividing line visually represents the exact undeniable rule that the machine just created out of thin air. Okay, it's test time. The machine has its rule. If a new student comes along and studies for exactly 7 hours, what is the machine's prediction? You guessed it, the prediction is a resounding pass. By applying the rule it learned from historical data to a brand new input, the machine has successfully executed supervised learning. It's incredibly empowering once you understand how that actually works under the hood.
Moving right along to Section 4, Common Mistakes. Let's look at a few pitfalls.
Honestly, busting these myths is going to put you way ahead of the curve. First off, beginners often think machine learning is just advanced coding. It is not. As we've seen, it's really about understanding and shaping data. Second, people totally ignore data quality. Listen, if you feed the machine garbage, biased, or bad data, it is going to confidently give you terribly wrong predictions. And third, people constantly confuse the 3 types of learning, but not you, because we have a solid mental framework for this now. And that brings us to Section 5, Summary and Final Test. Let's lock this in.
So, the crucial point is this. Machine learning simply means computers learning from data instead of explicit human programming. If you're feeding the machine labeled data like an answer key, that's supervised learning. If there are no labels and the machine is flying solo to find hidden patterns, that's unsupervised learning. And if the machine is learning purely by trial, error, reward, and penalty, like riding a bike, that is reinforcement learning.
To make sure these concepts really stick with you, drop your answers to these 2 practice questions down in the comments. Number 1, email spam detection is which type of learning? Number 2, grouping customers without labels is which type? But before we go, I want to leave you with a much bigger question to ponder. If machines can already teach themselves to find patterns that the human eye completely misses, what happens when they start learning things we don't even have the capacity to understand yet? Thank you so much for learning with me today, and I'll catch you in the next explainer.